Hey guys, this video is going to address a new method of evaluating functions called synthetic substitution. This is just a quicker and simpler way to evaluate what a function is at some given point, x. So you're used to seeing functions as f of x equals some function. In this case, it's 5x cubed plus 3x squared minus x plus 7. Now, when we evaluate this function at the point x equals 2, all we're doing is looking at f of 2. We're substituting in 2 anywhere we see x in this function. So substituting in, we would get 5 times 2 to the third power plus 3 times 2 to the second power minus 2 plus 7. Now we can just do some arithmetic and solve this problem. 2 to the third power is 8 times 5 gives us 40. 2 to the second power is 4 times 3 gives us 12 minus 2 plus 7. And all said and done, this looks like f of 2 is going to equal 57. So what this means is at the point x equals 2, our y value, or f of x, is going to equal 57. Now let's take a look at the same function, only this time we're going to evaluate x equals 2 using synthetic substitution. So our function f of x is the same, 5x cubed plus 3x squared minus x plus 7, and we're evaluating where x equals 2. Take a second and copy down these 1, 2, 3 steps. Press pause. Now these 3 steps are the mechanics we're going to go through in order to apply synthetic substitution to evaluate this function. The first thing we need to do is draw a little L-shaped bracket. It's almost like the long division symbol, but upside down. So once we have our bracket drawn, we're going to proceed to step 1. We're going to write the coefficients of f of x in order of descending exponents. So when we look back at our function here, we have f of x equals 5x cubed plus 3x squared minus x plus 7. If we look at the exponential values of each of these pieces of the function, they're already in descending order. We have x to the third power, x to the second power, x to the first power, and x to the 0 power, which is just 1. So the first thing you need to do before you use synthetic substitution is make sure that your function is written in decreasing exponential order. Now we need to identify the coefficients of each term of this function. So our first coefficient, our leading coefficient here, is 5. Our second coefficient next to the x squared is 3. Our third coefficient attached to the x term is negative 1. And our fourth coefficient is just 7. The second half of step 1 says to write the value at which f of x is being evaluated to the left. So we're evaluating here x equals 2. So we're going to write the 2 outside the bracket here to the left-hand side. So this is what your setup should look like for synthetic substitution. Now we need to go through the mechanics. Step 2 and 3 involve all the mechanics for this process. If we take a look at step 2 here, first part of step 2 says to bring down the leading coefficient. Our leading coefficient is 5, so all we're going to do is take 5 and bring it right down and write it underneath the bracket right here. The second part of step 2 says to multiply by the x value. We're going to take the number that's underneath the bracket here and multiply that number by this x value. 5 times 2 gives us 10. And if we look back at step 2, we write the product under the second coefficient. So we're going to write the 10 right underneath the 3, which is our second coefficient. And the very last part of step 2 says to add. We add 3 and 10 to get 13. We've completed step 2. Now we move on to step 3, which is to just repeat step 2. We take our new term that's underneath the bracket here, the 13, and we multiply the 13 times our x value of 2, and we get 26. We write the 26, same time as before, but right underneath the next coefficient. Again, last part of step 2 is to add. Negative 1 plus 26 gives us 25. Now we have that 25. We multiply the 25 by our x value of 2, and we get 50. We add 1 last time, and we get 57. The same answer we got from the original problem, where we actually substituted the value of 2 in for each of these x's in our function. So this is just a different way of approaching evaluating a function at a given value, and I think this way is a little bit easier. Let's take a look at another example. Here we have the function g of x equals negative 2x to the fourth minus x cubed plus 4x minus 5, and we're going to evaluate this function at x equals negative 1. Take a second, press pause, and just set this problem up using the bracket like we did in the last problem. Here's what the setup of this problem should look like. Now, many of you may have missed this 0 term in the middle here. Now remember, step 1 says to write the coefficients of f of x in order of descending exponents. So let's take a look back at our function here, g of x. We have negative 2x to the fourth power minus x to the third power, and there's no x squared power in this function. So we need to account for that no x squared by literally plugging in a 0 for where our x squared term would be. 0 times x squared is just 0. So each term has to be accounted for. So whatever your highest starting power is, in this case it's x to the fourth, you need to have an x to the fourth term, in this problem is negative 2, and x to the third term, which is negative 1, an x squared term, which is 0, an x term, which is 4, and a x to the 0, or constant term, which is negative 5. So when you set up a problem for synthetic substitution, you need to make sure that every exponent has some kind of coefficient attached to it, even if it's not seen in the actual function itself. In this case, we have no x squared term here, but we need to account for it by using a 0 as the coefficient for x squared. Take a second, press pause, and use synthetic substitution to evaluate this function at the value x equals negative 1. Here's what you guys should have got. So we'll walk through the mechanics real quick. Our leading coefficient is negative 2, so we bring down the negative 2. Negative 2 times negative 1 is a positive 2. We write that under the next coefficient. Negative 1 plus 2 gives us a positive 1. 1 times negative 1 gives us a negative 1. We write that under the next coefficient. 0 minus 1 gives us a negative 1. We multiply negative 1 by negative 1 to get positive 1 under the next coefficient. 4 plus 1 gives us 5. 5 times negative 1 gives us a negative 5. And negative 5 plus negative 5 gives us a value of negative 10. So when we evaluate this function for the point x equals negative 1, we get a y value of f of x equals negative 10. Here's a couple practice problems for you guys. I'd like you to use synthetic substitution to evaluate these functions for the given value of x, and we will go over these next class. See you soon.